An understanding of inertia and force provides the basis for developing a general description of energy. But before we get to energy, we need to define work. In physics, work is the application of a force over a distance. It is calculated as force times distance. This allows us to determine the units. Force is measured in newtons and distance in meters, making the units for work the Newton meter. This is such a common unit that it has its own derived unit, the joule. Let's look a little closer at what it means to apply a force over a distance. If we start with a person ready to throw a ball, before the start of the throw, no force is being applied to the ball in the direction it is about to be thrown. Its speed in that direction is 0. As the person starts the throw, he pushes on the ball, applying a force, which is the acceleration of a mass, so the ball starts moving in the direction of the throw. The thrower continues to apply a force to the ball the whole time his hand is in contact with the ball. Once the thrower is no longer in contact with the ball moves off due to the work that was done to it, even though the thrower is no longer applying a force to the ball. No more work is being done. The ball continues to move in the direction thrown due to the change in inertia, even in the absence of any additional force. The work done on the ball by the thrower occurs only over the distance the thrower accelerates the ball prior to losing contact with it. It is a measure of the number of newtons of force the thrower applied over the distance of the throw. Work and energy are related because energy is simply the ability to do work. Since it describes the ability to do work, it has the same units as work, which is the joule. We deal with two types of energy: kinetic energy, which is the energy of motion, and potential energy, which is the energy of position. A person holding a ball in the air above the ground is an example of potential energy. There is energy associated with its position above the ground. This potential energy can be converted to kinetic energy by letting the ball drop. Notice that in this example, work has to be done in order to raise the ball off the ground in the first place. In other words, work had to be put into the ball by raising it into the air in order to give it the initial potential energy. There are different forms of energy. These are mechanical, thermal, electromagnetic, nuclear, chemical, and electric. The ability to convert the potential energy stored in the position of the ball to the kinetic energy by dropping it shows that energy can be converted from one form to another. This is true for all forms of energy. Nuclear energy can be converted to electromagnetic energy. Electromagnetic energy can be converted to chemical energy. Chemical energy can be converted to thermal energy. Thermal energy can be converted to mechanical energy. And mechanical energy can be converted to electrical energy. In fact, any form of energy can be converted to any other form. At a basic level, they are all different representations of the ability to do work. It is transformations of energy from one form to another as it passes through the Earth system that drives climate and supports life. All of these forms of energy play important parts in our lives. In the context of studying the Earth, climate, and life, nuclear energy from the sun is the primary source, and thermal, electromagnetic, and chemical energy are the ways that the energy moves through the system.